Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. So, in the last episode what we did was we got our variables exposed to the level editor. So that's a huge step, and it allows us to start the next step, which is to actually start building levels. So, what we're going to be doing in this episode is actually building a menu where we can click onto different items and we can tell which item we clicked on. And then we're also going to start doing a screen coordinates to world coordinates conversion. So we're going to look at how we can do that, and then we're going to get both of those things done. So you should see a little bit of something of what we're working towards in the preview above, and that is what we will be working towards in the next few tutorials. Okay guys, so without further ado, let's get started. Okay, so the first thing we're going to take a look at is how we can get our icons in our menu to do something like this. So ImGui does not natively provide a way so that if you resize the window to the left and the right, the icons will resize with the window. You have to do that manually, but I will provide a link in the description where the creator of ImGui has actually just shown you how to do it. It's pretty simple. If you just think about it. So we're just going to draw it out so you guys know exactly what we're doing when we start to code. Basically, what we have to do is we have to first get a hold of the Windows X2. So the Windows X2 is this point right here. Then, as we start placing icons onto the window, what we do is we get a hold of this point and we get a hold of this point. We can get a hold of this point if we know this point. So we'll call this point our last X2, and then we'll call this point our next X2. Okay, and so what we're going to be doing is we're going to be iterating through all the icons we want to be up here, which is basically just all the images in our sprite, right? So we'll be starting from here. When we're on this iteration of an icon, we will be getting a hold of this X2, and we'll be getting a hold of the next X2. Then when we move to here, this will be the last X2, this will be the next X2, and we continue to do that. And then what we'll do is we'll say once we get to here, we would be right here, and this would be last X2, and next X2 would be somewhere out here. And so we'll say if next X2 is greater than window X2, and you could do greater than or equal, it just depends on your preference, then we go to new line. So we'll say next line please, and we'll just use ImGui's functions to get all this functionality that we want. And then this will ensure that our icons will just readjust accordingly. And we'll be building this every frame, so it's fine that we have it this way, because basically if this resizes, window X2 will change, and then we can, once again, we'll be running this loop again, and then all of them will adjust dynamically. Okay, so it's not too hard to understand. It's just nice to have a visualization of what exactly we're going to be doing. The next part is a bit trickier. So this was really difficult for me the first time I did this, but it doesn't have to be. It's actually quite simple once you know the math behind it. Okay, so I have a picture of a screen here. The screen's actual width is 1920, its actual height is 1080, and we have its projected width. So this is just like pretend. So pretend its projected width is 1280, its projected height is 720. So that's the world width, and the world height, you could say that's visible on this window. Then we have a camera X, right? Say the camera X is at 500, the camera Y is at 20. So in world coordinates, this bottom left point is actually at 520, but in screen coordinates, it's at 0, 0. At world coordinates, this bottom right corner is 1780, 790, I think that is. No, that should be 740, maybe. And then in screen coordinates, this is 1920 by 1080. How do we convert from these screen coordinates to these world coordinates? And that can be a little bit tricky if you don't know how to think about it. So I Googled a lot and I found some different answers, and then I found the one that I thought was the most appropriate. So if you remember in our shaders, what we do is we say GL position equals our projection times our view times our A pose. What is this? Let's just get a little refresher. Projection. The projection is just this stuff. It's how big we want the screen width to actually be. The view, what is that? That's just our camera position, our camera orientation, all that stuff. What is A pose? Well, that's like the actual position of the objects in world space. So that would be like these actual specific coordinates. GL position, what is that? That's a normalized device coordinate. That means it's a screen coordinate ranging from -1 to 1. You may be thinking, how the heck does this help us at all in this situation? None of these translate back to 1920 by 1080, but one of them does translate back to 1920 by 1080. This minus 1 to 1, we can get very easily from this 1920 and this 1080. So basically, in normalized device coordinates, this left corner would be minus 1, this right corner would be positive 1, this bottom corner would be minus 1, this top corner would be positive 1. These might be flipped in OpenGL, I'm not sure. But the gist of it remains the same. You have the minus 1, you have the positive 1, and you need to get from 1080 to this, right? From 0 to 1080 to minus 1 to 1, and then same here. That's not too hard to do, right? So if you have a point in your screen, say right here, how do you get that in range of minus 1 to 1? Well, you would just say, okay, it's x, y. If we divide that, so first we say x divided by 1920, which is the total width that you could have, and you say y divided by 1080, which is the total height that it could have. This will normalize it. This will get it in a range of 0 to 1. Now, that's not minus 1 to 1, but it's close. So then, to do the next thing, all you would have to do is you would have to say multiply these by 2, subtract 1, and that should normalize it so that it is now in a range of minus 1 to 1. And if you think about this, this will always work. So say this is 1920, that would be 1. Say this is 1080, that would be 1. So 1 times 2 is 2. Minus 1, you get 1. Say these are 0. 0 times 2 is 0. Minus 1, minus 1. And then you get everything else in between. So this is our conversion factor to get from 1920, 1080 to minus 1 to 1. So then how do we use that information? Well, we have a direct mapping right here, right? So this is world coordinates. This is minus 1 to 1 coordinates. We just do the reverse of this. So if we want to get world coordinates equals from here, you would say, well, this is GL position times inverse projection times inverse view. Those inverses are important because we can't just say 1 over P. If you're thinking in terms of numbers, you would be like, oh, if I have 10, the opposite of 10, the inverse of 10 is 1 over 10. That's true, but in matrices, the inverse is not 1 over the matrix. So we have to be very careful in our wording here. We can't just do 1 over P and 1 over V. We have to do something different. But basically, all the inverses too is just the reverse. So what we're saying is we want to reverse what we did. We want to go from GL position to reverse to reverse. So we take this minus 1 to 1 coordinate, multiply it by P inverse, multiply that by V inverse, and we get our world coordinates, and that works perfectly. So as we're coding this, I'll sort of show you the different steps too, just so that you can prove to yourself that it all works like you would think. But that should cover it. Let's actually get started, and we'll do the first part, which is the icons, and then we will do our mouse projection coordinate thingies next. Okay, so I'm inside of our level editor scene here. Let's just run this one more time so that we can get a visual representation of where we left off. There we go. So we just had an ImGui window, and we have our little color picker and everything, and we have this test window, which currently does nothing. Just gonna move these over a little bit. Okay, I have a to-do in here too. So remember, the texture was broken. These to-dos are helpful because it reminds me we need to fix it. We'll save this for now, but we will get around to it eventually. Now, let's go into our ImGui. So this is where we're going to be creating those icons because we want to create it inside of the ImGui window. First of all, let's actually make sure we're always creating the sprites. So let's make sure we are always loading the sprite sheet just in case, because if we're not, we'll get a null pointer exception when we go down to here. And I'm actually going to change the sprite sheet too. So currently we're using just a standard sprite sheet thingy. So we're currently using like character sprites. I'm actually going to use this sprite sheet right here, which is the decorations and blocks inside images. You can get this off of my GitHub if you want to, or you can just use whatever sprite sheet you want. So I'm going to go images, assets, images, and then sprite sheets and decorations and blocks. And then I'm also going to go down here and fix this loading. So this is actually in sprite sheets / decorations and blocks. Copy that, and we'll just add an S there. Do that one more time. They have the same width and height, the same spacing, but we now have 81 sprites. So that should be good. We should be loading the correct sprite sheet now. Now, if we actually go to build the window, this is literally taken straight from the link in the description. So what he says to do is first get the window position. In Java, it's a little bit more annoying than in C++ because we cannot pass around references easily. So we'll say get the window pose and store it inside of this variable we just created called window pose. And that will get the current position of the window. Then we're going to say ImVec2 get window size. So we want to get the window size too. And then we want to say ImGui.get window size and put it inside of that window size. And that should be new. Then we will say get the item spacing, because that is something else we will need, and put it inside of this variable item spacing. So we'll say ImGui.getStyle.get item spacing and put it inside of there. Next, we will calculate x2. So Windows x2 we can now calculate, which is just the Windows position.x plus the Windows size.x. So that is the rightmost coordinate of the window on the screen. Then we'll say for int I equals 0 until I is less than sprites.size. Let's create that function real quick, and we'll say I++. Let's go into our sprite sheet, just add a function really quickly. Say public int size return sprites.size. Go back into level editor scene. And now as we're looping through the icons, we can do our little place the image and then put it on a new line if we need to. So we'll say sprite equals sprites.get sprite I, and we do need to get a few things from it. So we need to get its width, its height, its texture ID, and its texture coordinates. So we'll say float sprite width equals sprite, and we may have to create these functions, which we will do in a second. And then we'll say float sprite height. And these aren't like the actual sprite's height. This is going to be the width and height we want it to be. We'll say sprite.get height times 4. And then we'll say int id equals sprite.get text id. And then vector 2f text chords. This one we actually do have done. So we'll say sprite.get text chords. Now let's create these functions real quick. Shouldn't take too long at all. So we'll go into sprite, and I don't think it currently has. Let's remove this too. We no longer need these constructors. Let's put private int width and height, or actually let's make these floats, width and height. Then we will go down here, create getters and setters, and actually somebody told me there is a way to generate these functions, which I will try real quick. So if we go to code and then generate, we'll say getter and setter, and we'll do both of these. So we'll say width and height, okay. Well, that's pretty cool. So thank you for whoever shouted that out. I can't remember, I'm sorry. But now we can have those generated automatically. Okay, let's go into the sprite sheet now because we do want to set the width and the height as we are creating these. So when we're creating it, we'll say sprite.setWidth, and then we'll give it the sprite width and sprite dot, this is inside sprite sheet too, by the way, sprite height. Because we're getting the sprite width and sprite height here. These are uniform, and then we just set them here so that we know what it is. And we do also want to create a text ID. So back into sprite, and we can actually just go down here. We'll just say public int get text ID, return texture equals null. If it's null, then we'll return -1. Otherwise, we'll return texture.get ID. And let's go into texture real quick and just create a getter for that. And we have the text ID. We just need to create the getter. So we'll say public int get ID, and then we'll return text ID. There we go. So now we should be good. We got all of these done. Next, we actually want to place these onto our ImGui window. So we'll say if ImGui.image button, which is exactly what we need. It takes in a texture ID. Well, we just got that. The ID. It takes in a size for the X. Well, that's the size you want it to appear on the screen, and the height you want it to appear on the screen. Now, UV0, X, and Y determine what size it actually is on the texture. So we'll use our text chords, 0.x, text chords, 0.y, and then we'll use text chords 2.x and text chords 2.y to get all of those done for us. And that should be good. This is a long statement. Take a look at it real quick. And then I'm going to open up my brackets for that if statement. For now, we will just say system.out.println button, and then we'll say +I plus clicked. And let's go ahead and calculate whether we want the next one to be on the same line or not. So we'll say ImVec2 last button pose. So this is the last x2 type thing. We'll say new ImVec2 ImGui.get item rect max, and then we'll give it last button pose. This will get the last button's position, which is actually the button we just created. We'll say float last button x2 equals last button pose.x. Then we'll say float next button x2 equals last button x2 plus item spacing dot x plus sprite width. And that will get us the next position for the next x2. Then we can say if I plus 1 is less than sprites dot size and next button's x2 is less than Windows x2, we want to place the next button on the same line. So we'll say ImGui.sameLine, and what this does is it will place the next item on the same line as the current item. So next time we run this, it will be on the same line as the previous image button that we created. Okay, and that should be good. Let's run this, see what happens. We should get some buttons, and look at that. We get buttons, and you'll notice they resize. But I'm gonna click here, click here, click here. We should have gotten 3 button clicks, but watch what happens. We get button 0 clicked, nothing else. Why did that happen? So you might be confused at first if this happens, but it's perfectly fine. The reason this is happening is because ImGui uses an ID system, and it uses IDs to determine if something's clicked or not. The ID it uses in the case of an image, however, is its texture ID, and these all have the same texture ID because they're part of a sprite sheet. So what we have to do is say give each of these a custom ID. So we'll say push ID, and we'll just give it the index they're at, which is I. And you don't have to worry about this clashing with other windows because the IDs are just according to a single window. So since we're making one window in here, we can use I and be perfectly fine with that. And then we'll say ImGui.pop ID. And what that will do is it'll give the button the ID that we just placed in here. Now if we run this again, and we click here, then here, then here, you'll notice we get button 0, button 11, button 36. Cool. So that's the first half of our thing done, right? We have a resizable window that actually detects when we click things. Next thing we have to do, because this is going to be important for our next tutorial when we actually start to drag and drop things, is fix up our MouseListener so that we can get some screen to world coordinates. So let's go to our MouseListener, and we will go down here right below get x and get y. We'll say public static float get ortho x, and we'll do public static float get ortho y. And before we can actually implement these, we have to go to our camera because we do need a couple more things. So we have projection matrix, we have view matrix. Let's also add in inverse projection and inverse view. Now when we go into here, we want to initialize these. So we'll say this dot inverse projection equals an empty matrix 4F. This dot inverse view equals an empty matrix 4F. That's cool. Every time we do an adjust projection, we would like to say projection matrix dot invert into our inverse projection. So this will invert our projection matrix and put it inside of here. Every time we do a view matrix, we would like to do this dot view matrix dot invert into our inverse view. Once again, we'll invert our view matrix into this matrix. Then we want to create a couple getters for these. So we'll say matrix 4F get inverse projection, return this dot inverse projection, public matrix 4F get inverse view, return this dot inverse view. All right, so let's go back to our MouseListener and actually implement that thing we talked about. So first thing we're gonna do is say float current x equals get x. And I'm gonna return -1 here too so that we don't get any errors for now. Then we're gonna say current x equals current x over float window.getWidth. So that should convert it to a 0 to 1 range. Let's actually just print this out real quick, just so that we know this is working. So we'll say print line. I'm gonna go to my level editor scene and we're just going to say inside of our update method, MouseListener dot ortho x, get ortho x. So let's run this, and then gonna make my window a little bit smaller. So if I move my mouse over here, we should be getting something like 0, and then if I move it over to here, we should be getting something like 1. And we're getting nothing. Did I forget to print it? Oh, yeah, it would help if we're actually printing the value. So let's print current x, okay? And then we'll run that one more time. So if I go over here, we get 0. If I move my mouse to the right, we get something very close to 1. Okay, so that part works. Now, like I said, if we multiply this by 2 and subtract 1, it should convert it to -1 to 1 range. So let's see if that's working. So if I move my mouse to here, we get -0.9, very close to -1. 0.99, very close to 1. Okay, so that part's working too. Next part. We're going to create a temporary vector 4f, a new vector 4f. We're going to give it current x, 0, 0, and 1. Do not forget that 1. It is important to maintain the integrity of our matrix multiplications. So we need a vector 4f too, because you can't multiply a matrix 4f by a float. You have to multiply it by a vector 4f. So we'll say temp.multiply window.getScene .getCamera or camera .get inverse projection .multiply window.getScene .camera .get inverse view. And what is this going to do? It's going to sort of undo all the operations to get it to screen coordinates, right? So now we should be getting world coordinates for our current x. Let's run this one more time, see what we get, see if it looks like something we would believe. So if we go to the left, we get -1. That's because we never actually changed current x. Let's change current x here. We'll say current x equals temp.x, so that we actually set it to the new value. And then if we go back into here, and we move our mouse to the left, we get -212. And to the right, we get 1030. That sounds right to me. Let's just double check. Level editor scene. The camera starts off at -250. And if we look at the camera's width is 32 times 40. So we should be getting -250 and then -250 plus whatever 32 times 40 is. So 1030, I believe, is what that is. And then we were getting -212. Let's run this one more time just to make sure. So if we run this one more time and we get really close to the left there. Okay, yeah, so it's -248. This is working good. So now we're getting world coordinates, okay? That's not too bad, right? This took me like hours the first time, and I don't even know what I was doing, honestly. It was not correct though. So yeah, this is the correct way to do it, and it's actually not that bad. Let's just copy this and do the same thing for our y. So we'll just change this to current y, not t, current y. Change this to current y, that to 0, and make sure you actually put it in the y direction this time. So y equals, and we want to make sure we do y. Okay. And that should be it. So now we have a way to get mouse coordinates in world coordinates. So since this is done, in the next tutorial what we can do is we can actually start getting around to clicking these and dragging some object that is this into our world. And then I also want to get into mouse picking, which means we'll be able to click on this, and then our inspector will be inspecting this object. And if we have more objects, we can click on them. Inspector will inspect those objects. All right, that has been it for this tutorial though. I hope you guys liked it. If you did, please hit like and subscribe so that you can get notified of when we do the next tutorials. And like I said, in the next tutorial, what we're going to be doing is actually implementing that drag and drop functionality. All right, guys, thanks for watching, and I'll see you next time.